Hello everyone, my name is Arnaud David from EUMETSAT and my presentation today is about fiducial reference measurements for SST and IST. The presentation is made together with my EUMETSAT colleagues Gary and Igor, plus colleagues from the Copernicus Trusted project from CLS, NKE, Meteo-France, the SHOM, BSH, OceanOps and DMI. The outline of my talk is as follows. I will talk about fiducial reference measurements for sea surface temperature to begin with, describing high quality reference SST from the Copernicus Sentinel-3 SLSTR instrument and the need for fiducial reference measurements for validation. Then I'll give an update on the Trusted project to provide FRM for SLSTR-SST validation. There will be an update on recent work regarding uncertainty diagrams and metadata and quality control. I will show some recent results of SLSTR-SST validation with Trusted and give an overview of the ongoing international coordination. In the second part of the talk, I will give an update of an activity which began 2 years ago to start the development of FRMs for sea ice surface temperature. Global satellite SST validation. Reference surface data such as from drifting buoys, Argo, buoys, and radiometers are essential for satellite SST validation. Validation activities are crucial to assessing and maintaining satellite SST product quality. This means co-locations with all drifting buoy SST, Argo, and the GTMBA. In addition, validation activities include intercomparisons with other satellite data, and in the case of climate quality and reference satellite SSTs, it is also necessary to do comparisons with fiducial reference measurements or FRM. The map shows an example of available global in situ data and in situ FRM data are collated with satellite data in the multi-matchup dataset produced at EUMETSAT. The sea and land surface temperature radiometer, SLSTR, is flown on the Copernicus Sentinel-3 satellites. The first Sentinel-3A was launched in 2016 and the second in 2018. The third, Sentinel-3C, is planned to be launched in 2025. High-quality operational sea surface temperatures from SLSTR provide reference SST and sea ice surface temperature for the marine domain. The significance of these data is increasing as the climate crisis amplifies. Therefore, high-quality reference FRM data for validation are also critical to ensure the satellite SST data quality, uncertainties and stabilities. This slide describes the definition of fiducial reference measurements. The validation of climate quality and operational reference satellite sea surface temperature requires a subset of extremely high quality fiducial reference measurements. This means traceability for climate data records to understand how accurate products really are and to deliver the required confidence. It means long-term investment, so balance to give a satellite mission with a known product quality that is fit for purpose. And it also means global coordination to increase the quality in the whole network, which is beneficial for both satellite and ground-based users. The Copernicus FRM Drifting Buoy project, or Trusted, began in 2018 to establish sustainable fiducial reference measurements for satellite SST and IST. Over 187 SVP BRST high-resolution drifters have been deployed so far, with both TRST and SST sensors. TRST is the new one designed to the GHRSST specification, and the SST sensor is the original traditional sensor. The FRM's drifters have calibration per sensor, metadata access, storage and QC, plus stability analysis. Recent developments have included traceability diagrams and metrology, together with coordination with the European Metrology Network. There has been recent focus on high-latitude deployments, as well as in the Baltic and Mediterranean seas, as well as global. The drifters deployed in the closed seas have a decreased lifetime to the global ocean. We have deployed in these regions as there are needs in these areas, but we need to balance that with getting more availability of measurements. Here is a map of all the quality control measurements so far, together with a link where you can find more information. This slide gives an overview of the Trusted Drifter, which is an SVP buoy with a new BRST design by the NKE manufacturer. It is compliant with the WMO Data Buoy Corporation Panel guidelines and has 4 sensors, 2 for SST plus air pressure and hydrostatic pressure. Some technical specifications can be found on this link. This slide gives an overview of the recent and planned deployments, which are coordinated by Meteo-France. We had recent deployments in the North Atlantic, Indian Ocean, North and South Pacific Ocean, and North and South Atlantic. Deployments are coming up in June 2024 in the Indian Ocean, Arctic, and South Atlantic. So these will contribute to a gap we currently have in the Pacific. There has been significant work in the last year of the development of traceability trees and uncertainty diagrams. FRM require full uncertainty model and traceability diagrams with an example such as from Berenford's work with radiometers. More recently, Marc Lucas from the SHOM in France has been leading the development of these for the Trusted FRM buoys. So these aim for an uncertainty model per buoy with specifically defined measurand. These are defined for a drifting buoy SST at a depth of sensor and a specific measurement time. Coordination with the European Metrology Network continues, and this gives an independent review and contributions by expert metrologists. This is critical to ensure the fiducial reference standard is met. It is also important to consider the link from the in situ to the satellite measurements, including uncertainty diagrams, addressing validation methodologies such as skin to depth models. Another step towards FRM compliance is machine searchable and accessible global and measurement metadata. This means the specification of a full QC procedure and a definition of the process to FRM. In this way, quality control data is propagated through full data acquisition and processing steps, and it is easily available to users. Methods are in progress to automatically include OceanOps metadata and Meteo-France and Coriolis QC data. This slide shows some SLSTR SST validation using trusted drifters. The trusted SSTs are included in the SLSTR matchup database and are available on request. The validation analysis is currently ongoing and incorporating the utilization of full metadata and QC. Some considerations we are thinking of is whether to use traditional drifting buoy validation methods or to treat trusted in a similar way to GTMBA and shipborne radiometers for a long-term stability analysis. This would have impacts on deployment planning to ensure the longest lifetime possible for each buoy for the stability analyses. Coordination with the WMO DPCP has been ongoing for the last 10 years. This started with the joint DBCP GRIS pilot project to improve the definitions of high-resolution drifters. Most global drifters are now meeting this specification. In addition, separate definitions of GHRSST2 and FRM were discussed at a recent DBCP meeting. GHRSST2 meets the original joint DBCP GRIS definition, but with machine searchable and accessible global metadata information. The FRM definition for drifters builds on the GHRSST2 definition. And this also includes calibration per sensor in a laboratory independent of sensor manufacture, definition of uncertainty budget traceability diagram, measurement metadata and improved quality control, coordination with national metrology institutes and the European Metrology Network, post-deployment calibration and analysis where opportunity. This is also linked to the activity that Gary is coordinating with the Task Team 3 on GHRSST drifters for satellite SST validation. The last few slides describe the work towards development of FRM for CI surface temperature measurements. FRM for CI surface temperature measurements. Development has been progressing fast at EUMETSAT towards high quality satellite CI surface temperatures, or IST. IST is classified as an essential climate variable with requirements of 1K total uncertainty. Poor coverage of IST in situ observations in the high latitudes limits the satellite IST algorithm development and validation. Developments towards dual view SLSTR IST, now pre-operational, require IST FRM for validation. Operational IST products are already available from the Aussie SAF. For further details on SLSTR IST, please see Gary's presentation from earlier in the week's programme. Therefore, given the progress with satellite IST, there is a critical need for FRM for IST. Within the TRUSTED project, the design and prototype is in progress to provide Copernicus FRM over CIs, which began in the TRUSTED project in 2022. A set of CI's buoy requirements has been written, led by DMI, and the link is there as follows. Last year, 2023, focused on the IST sensor design and the prototype. An example is seen with the probe at the bottom of the diagram. This year, 2024, focuses on the buoy prototype, testing and calibration activities. Testing, calibration, operational deployments and service will follow in 25 to 27. So for summary and conclusions, continuation of FRM is crucial for underpinning climate and reference satellite SST data quality, validating uncertainties and assessing long-term stabilities for climate data records. Activities on developing FRM for CI surface temperature is critical to continue for validating the new era of highest quality dual view satellite CI surface temperatures, for example from Sentinel-3 SLSTR. The TRUSTED project deployed over 187 SST FRM drifters since 2019, and IST prototype testing and calibration is underway. Further work is needed on documenting the traceability trees and uncertainty diagrams for the validation methodology, for example, the conversion of skin to depth SST, and also to consider the skin to depth in validation methodology. Considerations are needed on validation methodology for TRUSTED, for example, the traditional method of drifting buoys or using stability methods such as those for GTMBA and shipborne radiometers. Thank you for listening, and here are a few further acknowledgements and a couple of references and papers.